Dressed off the top of this. Now we're bringing this down in here. We're gonna do 2 holes, and then we're gonna take the turbo end mill 3/8. We're gonna go back and forth. This is supposed to be clearance for 3/8, and it's pretty close to 400 thousandths. This is guided on the side, so this doesn't have to be tight tolerance in here. In fact, you want plenty of room for anything that chips and things like that to fly in there. Alright, now this minus 3/8 would be 1 3/4. Actually, I'm going to take a look at this because I think it's a little bit long, or yeah, okay, we're gonna go there. We chose 1/800, 50 thousandths larger, because we're gonna be picking up a little bit extra off of our center line because we're gonna be going with a 400 thousandths width. So in reality, that radius is a little bit larger in the end as it is well on the width. This is extra material out here in the front. It's gonna be close to this. We're going to make a mat. We're going to go ahead and take the 3/8 cutter, and I think we're going to take like half the depth here. So we're just going to kind of like eyeball it. We're level with the top right there. And we're coming down about 250. Make it pass down, then we're going to put it down in the depth, make it pass back, and then we're going to go a little bit side to side just to make up the width on it. We got to the other side, we lowered it down, we're full depth now, and now we're going to come back the other way. Alright, we just went around, we went 20 thousandths each way, and kind of opened it up so that we got plenty of clearance in there. This is a 3/8 here. Alright, we got a slight little tension on this hold down nut here, and we've got the pivot set in place here, and we're holding it tight with a small Beasley clamp there, or Bessie clamp. And I'm going to go ahead and reset this toe clamp, or clamping this down to the table with it in line with the T-slot. And we're going to put the drill chuck in here, and we're going to zero in, and we're going to go ahead and machine this hole here. First, we're going to come in here and we're going to claim our ream diameter of a 1/2 inch in line with this pre-plasma cut hole that's going through both the plates here that are welded together. Once we claim that, then we're going to go ahead and we're going to poke through with a tap size drill, and then we'll lift this off of here and we'll run the tap on through, and we're going to create those 2 holes. So we're going to be tapped into the bronze, and we're going to be a ream diameter in the metal, so that that bolt will be able to shoulder down and tighten against the bronze piece and create a pivot. After we get done doing that, we're going to go ahead and we're going to take this piece of hex stock and put it in a lathe, and we're going to go ahead and machine the shoulder bolt that's going to support this swinging top half. Alright, now this is a piece of 7/16 in here, and the hole was plasma cut out just slightly under a half, and we went ahead and up and down, side to side, we got our alignment on there, and we're going to go ahead and we're going to ream that hole out at a 1/2 inch. Okay, we're just going to control the depth here, and we're looking right down at it. This is just some cutting oil just so we can ream out that hole, and that's pretty close to 0 as it is on the dial there now. And I'm holding this with my hand so I can feel any motion, plus I'm gonna be looking here. But this all looks pretty good here. Full depth. Looks like a nice clean hole. Not bad. It is pretty clean. We will go down through the rest with a hand reamer. There's just a little tiny lip right there at the bottom. Alright, we're just spotting that position right there. We're going to put a 3/8 National Course thread in here, so this is just a 5/16 tap size. We'll go ahead and we're going to bring it in with the tap follower here, and we got plenty of load on there. Alright, now this is bronze alloy, so it's not necessary to have any cutting fluid, but just to make them nice and crisp, we'll go ahead and we're just gonna put a dab of cutting fluid on there. And with the tap handle here, and it guiding straight in with the tap follower, which is a handy tool. I use it for a pointer also, but it is very handy to run small taps and keep them in line. It's not so much that it saves you any time, unless it's do-over time that you're saving, but it ensures that you are putting it in straight, and that's what we want. This is going to be a shoulder bolt. So we've got this set up straight, and we got this in line. And now that we make the bolt, we'll be able to bolt that up, and everything should mate up perfectly with each other. This is Shenan. He's a pretty hefty cat. Well, he's starting to take to the shop. He does pretty good. He hit the air nozzle and he's pretty well out of here, but you know, you need good mouses around, that's for sure. Don't be eating chips now. Alright, with the tapped hole and this width here, let's grab the veneers here. Okay, we're going to use this hex stock and we're going to make the bolt, and we're going to want our threads to come all the way through here. So the threads got to be at least you know, probably 550 or so would be comfortable. This is about a 1/2 inch here, and the reamed hole, that's 480. We'll just call that 1/2 inch, 500 thousandths. All right. And then just to copy the thick or tall head, we'll go ahead and we'll make this like, oh, I don't know, 3/8 or so on the head. We'll give it a slight roundiness on that side right there, but that'll be enough to flange out and create that pivot. Let's go to the lathe and start machining our bolt. See how nice and glossy that chip was when it peeled off around there? This is a piece of leaded stock, and most of my hex in the steel I did procure 12L14 material, which is an easy turning machining alloy. Alright, we're calling that 0, and we set our dial at 0. Now we're going to go in and we're going to cut in. We're going to go ahead and take it an inch and turn that diameter down to the 1/2 inch that we reamed the hole to. And then we're going to test slide our piece on there. Then we're going to turn down an inch long, or excuse me, then we're going to turn down a 1/2 inch long section for the threads. And then we'll single point those threads right on here. Now we're not going to use a center or anything else because our setup here is rigid enough to go ahead and cut those threads without any problem. And we'll probably spin on a test nut of 3/8 or so. The threads are going to draw in and tighten the face against the shoulder in there so that it'll be locking, and then the straight 1/2 inch section will be slightly longer than the width of the swing top piece there, so that it doesn't bind. Alright, verify it with our, yeah, we're short 100,000. And the diameter is 690. Okay, 50 will make it 590. .92 or 93, feels a little warm. We're going to grab our 1-inch micrometer. 94. Well, 514, 513. What are you up to, huh? You been somewhere, you got cobwebs all over. Oh, you went in the shelter, huh? You getting any mousies in there? Go get them. Okay, that should be real close, if not 100,000. Let's see. I mean, 1,000th's over, but right now we're about 1.5. We're miking 1.5 over. Still got a little temperature, but we can go ahead and we can draw file that if we need to. Just for curiosity, does it go on here? It's a little snug. Before we get it stuck on there. Okay, let's go ahead and we're going to take down our thread diameter now. That's 3/8 right on the money. Alright, that was 62 thousandths per side we actually were cutting on that. Alright, now we got to go ahead set up our threading. But before we do our threading, we're going to go ahead and put the D&MP in here. And we're going to come in and we're going to give just a little bit of a relief right down into the bottom here, so that we have some place for the thread to come out, have a place to come out and exit on our thread. Alright, now we said I think that's going to be good. We were talking 550 or so, but each of those pieces really are pretty, this is like 520. We can take a little bit off of there, and we'll be able to take a little bit off of there if we need to create the clearance in here as well. Alright, there's a little bit of relief in there. And my head was already set square from the last time we did a machine operation in there. Now we're going to be cutting 3/8 16, 81 thousandths is double depth, so we're only going to be going in about 40. But we're going to go ahead and we're going to kiss this outside angle here so we can get a good easy start on the thread. That looks pretty good, but well, let's check it. And we want alright, right on the money. Alright, we got a test nut here. And let's go. Couple spring cuts. Actually, let's just take one spring cut. Let's check our fit now. Alright, I like that. Now we almost go up to that shoulder. And we know that we're going to want to thread tight to that shoulder, and the nut has got a built-in little chamfer right here. So we're going to go ahead and we're going to grab our 3/8 die nut and we're going to put it on backwards just to go ahead and make sure that we get down in there nice and tight right there. Only because the amount of shoulder here and how small the thread, the pitch is, and how close I'm trying to carry it there, that's the reason why we're not in there. I just want to make sure that we got full contact with this surface right here. Alright, we're going to add a little bit of cutting fluid to our die nut. Now we turned our die nut on backwards, so you don't normally cut from this direction. But it screws on there pretty good. What that does is that just gives a real sharp edge right to your threads, all the way in close to your shoulder. Kind of a... Now die nuts aren't made to cut threads, and that's why I didn't just cram this thing on here and cut it, because I wanted nice straight true threads with the axis of the bolt there. Now if we screw our nut on, the nut should screw all the way to the shoulder, and it does. Comes in flush. Okay, let's double check our depth right here on this. We're gonna fit the slip on there and trim that back with a D&MP if we need to. Which you can tell I already feel that we are going to have to. Okay, out of the threading mode, and we'll see if the temperature has dropped and the size has gone down to 1/1000 over right now. And remember, this was just a little too snug. Okay. There we go. Okay, now what we want to make sure is that this sticks out. It does a bit. I'm going to give it a couple more thousandths on here. That doesn't need to be a tight fit. It just needs to not come off that pin there. Okay, now instead of having this face come right out to the points, I'm going to come here, I'm going to touch the points, and I'm going to take it, I'm going to create what they call a washer surface. I'm going to bring you in a different angle so you see that. Alright, we're going to put a washer surface right on here. So we're going to come in and we'll touch this face right there, and then we're going to back up, and then we're going to take 10/1000ths, and then we're going to come in until we have a round circle that's equal to the flats. And that will be called a washer surface. Minimum amount that you're going to take around there so that you create a round diameter for the bolt to tighten up to. Or not. Alright, so we touch. We take 10. A little bit more. Alright, now we got a washer surface right there. Okay, now we're going to go ahead and we're going to cut this off, and so we got the bolt itself, and then we can chuck on this in a small lathe in there and kind of give a little chamfer or prep on the top side of the bolt head. Now, we said that we wanted to make a fatty head here, and standard 3/8 head is about 330 or so. So we're gonna go ahead and make the head about 400 thousandths. Now we're gonna be parting in on them, and parting in on hex is the same as parting in on a round diameter, but you have an interrupted cut coming in. So that's where you want to make sure that you're really not gonna have a grabby part off tool. Really cuts nice. You almost don't have to put lubrication on it, but it just adds a little bit more to it. Okay, let's go in on the south bend, and we're going to put that on the in the 3-jaw chuck. And we're just going to face that off and put a slight little angle to the leading edge out here. Hey, look at that, huh? We sold that little shaper, the south bend shaper, and I'm actually able to put the camera where the shaper was and bring you in on that side of the, the lathe a little better. All right, now we're just in there. We're not, nothing's real fancy here. In fact, I think we're gonna go ahead and use this use this cutter, and of course. Okay, let's go ahead and speed this up just a bit. Okay, that's a little too high. Okay, now I'm going to go ahead and I'm going to run it in reverse because this cutter here that I've got in here, I can go ahead and put that angle that I want on there, and all I want to do is angle off the points of the bolt so it's not something that'll catch your hand. The other reverse. Alright, I'm just feeding it straight in until I get a good look at it. I'm going to slow it down so we can actually see. And we're starting that. I think we're done. You know, 12L14, you just saw how easy this stuff cuts. It is great stuff to play with when you're machining. And if you don't have to weld on something, this is great material to play with. And also too, I mean, if you've ever taken, you know, you ever cut the hex on a grade 8 bolt or something, all right, hex stock is not like that if you get the right material. All right, there's our bolt. Now we're going to go hit this with a wire wheel here. I think that old material, I mean, I haven't used that hex stock in a long time, so it's got kind of a rusty finish on there. And we go hit it with a wire brush, and that tends to take any of the little burrs off of here as well. Kind of gives it an old satin finish. Also, you'll see the difference in this. It'll almost look like an old bolt when I get done wire wheeling it. Okay, now I did say it looks like an old bolt, except for in the olden days, the top of the bolt was rounded. Like, well, I don't have anything that's really right here. Well, yeah, I do have a couple over on the Sibley that is actually like that. All right, let's go ahead and see what we have here. And a little tight. We'll go ahead and we're going to draw file that a little bit so it makes it a little slippier in there. We got this to fit in this a lot better. Yeah, it's still a little snug, but you know, it's got to wear, and this threads in fine, and we got it to where we know that that goes all the way into the shoulder. Alright, now we got the two pieces bolted together here. Alright, now it only goes up so far because this radius over here, and this is extra material on this back side. So now we're going to go unbolt this from the table, and we're going to go into the other room, and we're going to go ahead and grind the OD of the bronze so that this will take and open up. And it's not going to be much. I mean, you know, it's real close right there. In fact, actually the OD of this can almost be used as the guideline for that radius back here.